Welcome to Lesson 15B, All Things in Moderation. Chocolate has been a favorite food of humans for over 3,000 years, originating in Central America and Mexico, where it was enjoyed as a drink. It was thought to have certain medicinal properties and was even considered valuable enough to be used as money. Lately, studies have emerged that also promote the health benefits of chocolate. Question number 1, have you heard of any health benefits from eating chocolate? And if so, what were they? And some of the things you might have heard is that chocolate is an antioxidant. It is possible that it lowers cholesterol. It can reduce cognitive decline as you age. It could reduce reduce the risk of cardiovascular problems, of heart disease, of a stroke, etc. So write down anything that you've heard, and then let's go look at the objectives. So in the objectives, a couple for sure to point out: conclusions about cause and effect cannot be made in observational studies because of confounding variables. Conclusions about cause and effect can be made in experimental studies where confounding is controlled. Experimental groups created through random assignment can usually control variability among confounding variables. When we're done with this lesson, we should be able to analyze a statistical study and identify possible confounding variables. We should also be able to decide when confounding variables restrict our conclusions about cause and effect. And then finally, we should be able to design an experiment that allows conclusions about cause and effect. So in this lesson, we consider how conclusions in statistical studies can be uncertain when researchers do not know why a particular outcome has happened. So if you have not already hit pause and worked on question 2 and maybe question 3, go ahead and hit pause, work on question 2, and then come back and we can walk through some information together. And make sure you're writing down complete notes, ideas, using highlighters, sticky notes, anything that's going to help you to remember what we're talking about so that you'll be prepared when you go to the practice assignment and for the test and for any future courses you may take, especially if you get a master's degree. You'll be taking a statistics course, and this is the beginning of that, and this can set a good foundation for future courses. A research study in Sweden asked the research question: does chocolate reduce the risk of stroke? So there was a sample of 37,000 Swedish men, and they were divided into 4 groups based on their normal chocolate consumption. And this was ranging from someone who ate no chocolate to the group who ate 63 grams per week. We need to convert that pretty fast to ounces and see how much that is. We're going to leave it right there. It is important that the study included so many people because it makes the results more reliable. And the participants were followed for 10 years. The study concluded that men who ate more chocolate had a lower risk of experiencing stroke. Part A. Did this study prove that eating chocolate causes a lower risk of stroke? Remember, causes can only happen in an experimental study. So in this study, even though they were divided into 4 groups based on their consumption, nothing was manipulated. So therefore, this is an observational study. And if it is observational, you cannot say that there is a cause and effect. There may be other variables that can explain the lowered risk of stroke among the chocolate eaters. So part B, can we offer an alternate explanation for this lowered risk among chocolate eaters? Jot down some idea of what you think. It may be that people who ate more chocolate also tended to eat something else that could be contributing to lower risk of stroke. Or maybe they tended to not eat something that may contribute to a higher risk of stroke. Write down a couple of things here that you think, well, these could be something else going on other than what was observed in this study. Go ahead and look at question 3 on your own, and even go ahead and look at question 4. But look at question 3, hit pause, look at it, and then come back. In our preview, we read about confounding variables. If you have not already written down what these are or want to add to your flashcard or glossary, they are factors that give alternate explanations for an effect. When there are confounding variables, researchers cannot, let me go ahead and throw in some yellow on that one, cannot make inferences about cause and effect. Another article pointed out some important facts in the study described above. The men who ate the most chocolate tended to be younger. They were more educated, and they were less likely to smoke or have high blood pressure. They also reported eating more vegetables and drinking more wine. All of these factors have positive health benefits. Well, now that we know all of that, explain how this information sheds light on the study that says eating chocolate lowers the risk for stroke. Does this make us more or less certain about the effects of eating chocolate? There are lots of various things you could write down about the first question and the second one. A couple of things you might want to jot down. It tells us that chocolate eaters have other attributes, which may also contribute to this lower stroke risk. These other factors make us less certain about the effects of eating chocolate. Continuing on with part B, chocolate eaters tended to be more highly educated. What other confounding variables arise from this fact that may also cause a lowered risk of stroke? In other words, what other things do people who are better educated tend to have in common? Again, write down your thoughts, your ideas. You might want to add to it something like people who are more educated often make more money and thus have better health care. More educated people may eat better, they may exercise more, they may not, but they may. Education could lead to many behaviors that are beneficial for good health. All of these items are confounding variables. So cause and effect, conclusions, cannot be made in observational studies because of confounding variables. On the other hand, experiments allow such conclusions by holding confounding variables constant among several groups. To do this, researchers make sure, get your highlighter out, they make sure that groups are similar in terms of education, age, eating habits, so on and so on. Get your highlighter out again. When groups are similar, confounding variables are controlled, they're not varying, and it becomes easier to argue that the treatment, like chocolate, is the cause of the observed effect, like fewer people having strokes. To control for the confounding variables, researchers divide participants into smaller groups. Some groups are treatment groups and they receive the real treatment, and others are the control groups and they receive a placebo. It's fake, or even nothing at all. Control groups are used as a basis for comparison to the treatment groups. We're trying to find if something's different, if we can remove the confounding and make everybody the same, then hopefully any difference we see between the groups is going to be attributable to whatever we thought was the explanatory variable. Question 4. We want to design a new study to infer whether eating chocolate causes lowered risk of stroke. To do this, we compare a large group, big old sample size, of chocolate eaters with another large group of non-chocolate eaters. Now, this is a great time to make sure you have hit pause and to make sure that you have your answers down for parts A, B, and C, and then come back and let's walk through these together. Control, treatment. You might want to go Google these if you haven't already, but treatment, they're going to be the ones getting the real thing. Control, well, that's going to be the ones not getting the real thing or getting a placebo. And so in this case, the control is going to be the non-chocolate eaters, and the treatment's going to be the chocolate eaters. Would it make sense to allow the study participants to choose which group they are in? Explain possible consequences for such an approach. And the answer is very, very large. No, they are not allowed to pick which group they want to be in. And you jot down some reasons why, but allowing participants to choose their group would be a mistake, a huge mistake. Chocolate eaters would choose the chocolate eating treatment group, and the non-chocolate eaters would pick the other, the control group. Chocolate eaters probably have other factors in common that would make them, that could make the causes of any observed results unclear. And remember, we're trying to keep the groups pure so that the thing that makes the difference is the treatment. So as researchers, it is our job to create a control group and a treatment group, so that the confounding variables such as education or income do not interfere with the outcome. What should be our goal as we decide to assign subjects to our groups? Well, I would write down, jot down, highlight, underline the word similar. Our goal should be to make our groups similar so that the confounding variables are held constant. There are going to be confounding variables, but if everybody's got them and it's constant, then we have a better chance of saying cause and effect. In controlled statistical experiments, researchers try to, another big word, minimize the effects of confounding variables by creating treatment and control groups that are as similar as possible. Groups are similar when the confounding variables are held constant. In other words, on average, they're constant. They're the same from group to group. So let's finish up this lesson, starting at the top of question 5. You have gathered a group of volunteers. They're all in their early 20s, and they come from various socioeconomic backgrounds, and none of them eat chocolate, but they're willing to try it for the sake of the experiment. You want to divide them into 2 groups. One's going to be the control, one will be the treatment, and you're going to monitor their health for 40 years. Part A, devise a method for dividing. Part B, what are explanatory and response? Part C, with your method, suppose, and then we'll get to that conclusion. So part A, devise a method for dividing. And this is where you might Google methods for dividing, search your preference of internet on methods of dividing. You can think of what you would just like to try or do, or maybe you've been part of an experiment before. Here are a couple of possible answers. One, you could use a random number generator like we've been using in class to separate them into 2 groups. Volunteers who get an odd number are going to be in the control group, the no chocolate group. Those that get an even number, they're going to go in the treatment group. You could do something like that. You could carefully design the groups to be similar, matching them regarding diet, exercise habits, etc., and then randomly assign one person of each similar pair to the treatment and the other to the control. The sky's the limit on how you divide, but you need to be intentional in getting the groups as similar as possible. Part B, what are the explanatory and response variables of this study? And then are they quantitative or are they categorical? And I go back to what's going on here. And so what I believe we are saying is that chocolate is having an impact on your risk of stroke. If that's the case, explanatory is chocolate, response is the risk of stroke. Chocolate, is it, where are they, quantitative or categorical? The chocolate eaters, you're either going to be yes, you are eating it, or no, you are not, so it is categorical. And on the risk of stroke, sometimes I disagree with what's put out in our curriculum, and so I will go first that it is saying that our risk of stroke is either yes, you have a risk, or no, you do not. And I would like to think that if you had a certain percentage risk of stroke, it could go down, and then that would be quantitative. But if it's yes, you have a risk, or yes, you had a stroke, it depends. And reading through the stroke, it's just saying we're going to divide them into groups, we're going to monitor their health. I'm not seeing where it's specific. This is what they're wanting us to do of whether you had a stroke or did not have a stroke. My brain leans toward what's the risk of the stroke. So I will go with what they're saying, that either yes, I had a stroke or no, I didn't. And then that's going to be categorical. You jot down your thoughts and your arguments because I'm always asking you on the test to explain why you got your answer. And this is where the arguments come in very well of getting credit because I want you to be thinkers. Part C, with your method of dividing the volunteers into groups, suppose that the decades-long study concludes with significantly lower rate of stroke. See, this is why I think if it is a rate of stroke, then what's your rate after 40 years? And what's my rate after 40 years? So I think I can see both ways. I like this one better. But again, this is the one they're using for our curriculum, but I like this one better. And so then it says, among those who ate chocolate, write a sentence that infers the conclusion of the study. And so jot down something that you would interpret this as, and something we could say is that with this carefully designed experimental study, we can state that there is evidence. There is a cause and effect. There is evidence that eating chocolate is the cause for lower risk of stroke. So jot down something accordingly, jot down some thoughts as to what you think, but big picture, do you see the words that you need to highlight and pull out about random and putting them in similar groups? And can you pick out explanatory and response variables? And can you decide if they're quantitative or categorical or put up a good argument about either? I just want to throw out a couple more thoughts before we finish this lesson. First, about experiments. In experiments, we do attempt to control confounding variables by holding them constant from group to group. And just another reminder, the way we attempt to do this is by making our groups as similar as possible. And that's something you would write about in your study, about how you did it, what your intentions were, and how you believe that was done well. And then another thought I want to share is that one way researchers can make groups similar is to randomly assign them. And there are multiple ways for random, but to randomly assign them And a method of assignment is random if each group has equal chance of receiving any member. This concludes our lesson 15. Check out our syllabus, see if you have more lessons to do. If you do, keep going. If you don't, it is time to celebrate, and I'll see you again next week. And by the way, we only have 18 lessons in our curriculum, and we are flying through lesson 15. So we are almost done. Keep going. Don't give up.